Right. You can see here the minimum mode configuration of the 8086 microprocessor, right? So, so here you can see block diagram of uh, minimum mode configuration of 8086 microprocessor, right? So how you can say that this particular configuration is minimum mode configuration, right? So in the while discussing about the pin configuration of 8086 microprocessor, right, we have discussed this particular concept of minimum mode configuration and maximum mode configuration, right? So bit number 33 will decide it is going to be under minimum mode configuration or maximum mode configuration, minimum by maximum bar, right? So this is the pin, 33 pin is there, right, depending upon the condition, right? So you can say that it is going to be work in minimum mode or maximum mode. So you see, you can see here minimum by maximum bar pin, 33 pin, right? You can see here also, all right, in this diagram also. So if you connect this particular 33 pin to the high signal, right, high signal, right, high signal, then this is going to be called as a, this is going to be working maximum mode configuration, right? If you connect to the low, then it is, you can say that this is the minimum mode configuration. Sorry, high means this is the minimum mode configuration, right? So low means this is the maximum mode configuration, maximum mode configuration, right? So if you use this particular 8086 processor in minimum mode atmosphere, right, we need to connect this 33 pin to the 33 pin through the power supply, power supply, right, 5 volts. Otherwise, if you connect this one to the 0, then this particular processor is going to be working maximum mode configuration, right? So what is the difference between the maximum and minimum mode configuration, right? So minimum mode configuration means what, this is going to be working single processor configuration, right? In a maximum mode operation means what, it is going to be work with more than one processor. That means what, if you want to perform any task, more than one processor is coming to the picture to utilize this particular communicating buses as well as peripherals, right? In a minimum mode configuration, only one processor is coming to the picture to utilize or to communicate external peripherals, right? So this is the single processor configuration, this is the multi-processor configuration, right? So what is the difference between the single processor and multi-processor configuration, right? Apart from this, right, another thing is that some control signals are there, control pins are there, those are going to be changed from minimum to maximum mode configuration. In minimum mode configuration, those pins are going to be out some signals. In maximum mode configuration, same pins are giving other signals, right? So this is all we discussed in the pin configuration while discussing about the pin configuration. By this time you need to remember is that if 33 pin is connected to the 5 volts, processor is going to be work in minimum mode configuration, that means single processor configuration. If you connect to the ground, it is going to work in maximum mode configuration, right, multi-processor configuration, right? In minimum mode configuration, if we are going to discuss here a minimum mode configuration, that is the single processor is going to be used to communicate with external peripherals. What are the peripherals, right? Here normally we have, that is the memory, right? Then IO devices, IO devices, right? So to communicate in minimum mode configuration, we have a single processor that should be communicated with peripherals. Why? Because previously also we discussed whatever the processor has internally is that some CPU, internally some temporary registers, and some communication to communicate some bus interface unit is there, right? So there is no inbuilt IO device to the processor, as well as there is no enough internal memory to store the program as well as user data, right? So we need to connect externally memory as well as IO devices. What is the use of memory? Memory is used to store the programs as well as data. IO device is used to take the data and out the data. That is the reason we need to connect external memory and IO device to the processor. IO device to the processor. Then only it can read some data from the input device, as well as it can read some program from the memory. Based on the instruction, it is internally it will do some work on the input data, right? Then it's going to get finally some result. That result may be stored in the memory, or it is going to be out to the output device, right? So that is the process normally is going to take place. How we are going to be processing the data? As a human being, we are going to take some data from the inputs sensors, and we are going to be executing some logic. That program also, if big program is there, we need to write in the book, and one by one instruction we need to read, we need to decode in our mind, and we need to execute that one. Then finally you are going to get some data. That output data you can write in the book, or you can out to the any output device, right? That is the process is going to be takes place normally, right? So same thing, this to communicate through this particular peripherals, whatever may be the peripheral. Say you can see here also peripherals, you can see here also, right? RAM is there and ROM is there. This total memory and IO devices are there. IO devices are there. These three peripherals we need to connect to this particular processor through buses, right? Through buses. While connecting this peripheral device to the processor, right? This 8086 processor, right? We need to interface properly to make proper communication between these peripherals and processor. These peripherals and processor, as well as from processor to output peripherals also. To make proper data transfers between these peripherals and processor, we need to interconnect with some logic circuitry, right? To provide some communication signals. So previously also we discussed this particular one, that, right? So three buses normally is going to play major role to communicate to the peripherals. First bus is this particular one is the address bus. This is the address bus, right? So how many is a 20-bit address bus we have in 8086 processor, right? So what is the use of this address bus? Means it is going to be address some memory or IO. Once it is address memory, in the memory some register. In the similar way, if one among the n number of IO devices, that means whatever the data outing through the 20 address lines of the address bus of the 8086 processor is used to address one register among the memory or one device among the IO device. That means it is going to be addressing. First, once it is addressed, based on the control signals, right? We have some control signals. Signals are IO read, right? IO write and memory write. These are the control signals. These control signals we need to out from the processor to perform some task, right? Whether it's going to be read from the memory or write into the memory, or whether it's going to be read from the input device. So to perform any one of these four functions, it needs to be processor is need to be out the control signal. And another bus is there here, is that is the data bus. This is the bidirectional bus. Based on this particular control signal, maybe data is outer or in the data. This one is you going to say that data bus. Normally this is the 16-bit data bus we have in 8086 microprocessor. 8086 microprocessor, right? So these are the three control signals. We need to be that means processor need to be out to perform data transfers between the external peripheral and processor. External peripheral and processor, right? First thing is what? Processor need to be addressed. Processor need to be addressed one register among the RAM or ROM or one device among the IO device, right? Then it needs to give control signal, what operation it has to perform. Then it's going to be read or write into the memory, or IO device, depending upon the control signal, right? So here 8086 processor has a 20-bit address bus, 20-bit address bus, 16-bit data bus, right? We have, right, some control signals are there, right? So control signals are going to be generated from the control pins, right? So this is the way, the basic first point we need to remember, right? While communicating with processor and external peripherals, these three buses are going to be play major role, and it's a similar way. Processor need to be generate address first, then control signal, then data transfers will take place. Then data transfers will take place through data bus, right? To address, processor is going to use address bus. To generate control signals, processor is going to be use control pins, and data bus is used to transfer the data between the processor and external peripherals, right? You can see here memory. This one is what? Read only memory. This one is what? RAM. Read only memory means we can read only from this particular memory, right? So normally ROM we are going to use to store the operating system programs. OS we are going to use to store the OS. You can see here also, right? So this one is memory read control signal. It has only one control signal, that is memory read control signal. Why? Because you can read only, you cannot write into the ROM. But you can see here both control signal, memory write as well as memory read control signal. RAM is the read write memory. This one is going to be used to store the programs as well as data, right? So overall ROM is used to store the OS. Here RAM is going to be used to store the user data or user programs, user data as well as user programs, right? So what first we have, while communicating with processor, if processor want to get the data from the RAM, it has to out the address to select the one register among this particular after selecting the RAM, one register among the RAM, and then based on the control signal whether it's going to be read data through data bus or write into the memory, in the similar way it is want to read ROM data from the ROM, for example code from the ROM, it needs to select the ROM as well as it needs to select one register among this particular ROM. Then based on this control signal it's going to be read through data bus. In the similar way IOs also select the IO chip, then whether read operation or write operation based on the control signal. Data transfer will take place through the data bus, right? So this is the way it is going to be generated, it is going to be communicated, right? First we will see how processor is going to be produce the 20-bit physical address, right? We know here, right? So AD, what are the pins we have to to generate the address from the 8086 processor? We have a AD0 to AD15, right? A16 by S3, A16 by S3 to A19 by S7, right? S3, S4, S5, S6, 4, A16, 17, S4, 18, S5, 19, S6, right? So this is the what we have here 20 pins are there to generate the 20-bit address through the 20 address lines of the 8086 processor, but lower 16 lines are multiplexed with the data bus, right? See here, lower 16 lines are multiplexed with AD0 to AD15, right? Higher 16 lines, higher 4 lines are multiplexed with status lines, AS6 to 16 to S3 to A19 by S6, right? So these are multiplexed address and data lines. This one is multiplexed address and status lines, right? So we already discussed previously while discussing about the pin configuration, right? So one pin is coming to the picture, that is the ALE pin, right? If ALE is high, right, whatever the data passing through this address lines is the address, right, right? If it is low, whatever the data passing through this multiplexed address and data lines is the data or status. That means what? Based on the ALE condition, address latch enable condition, these lines should be produced output, right? If it is high, whatever the data coming out from this 20 address lines is acting like a address. If it is low, this lower 16 lines is going to be produced data, this one is status, right? You can see here how it is possible, right? So here if you can see, here you can see 74373 latch, right? This is 8 pin latch, right? 8-bit latch, you can say that 8-bit latch. That is the reason here it's going to be used 3 latches, 1 2 3, 8 address lines, multiplexed address lines are going to be connected to the first one, and another 8 is going to be connected to the second one, alright, and another 4 are going to be connected to the third latch, right? So multiplexed address and data lines as well as multiplexed address and status lines. So 20 lines, here you can see here 20 pins are going to be connected to the first 8 pins connected to the one latch, second 8 pins connected to the second latch, third 8 pins, last 4 pins are going to be connected to the third latch. That means 74373, right? So for every latch we have a strobe pin. Every latch has a strobe pin. That means ALE's pin is going to be connected to the strobe pin of 3 latches. Then 3 latches. Once you connected like that, what will happen, right? So if this is, for example, something is going to get through 16 address lines, multiplexed address and data lines, here 4-bit data through multiplexed address and status lines. Once it is high, ALE is high, what will happen? This ALE is going to give strobe signal to the 3 latches. Once this strobe signal is given to the 3 latches, what will happen? This is going to be activated. These latches are going to be activated. Whatever may be the input through these 20 pins is going to be out through 3 latches like this. That is going to be A0 to A7 is going to be give address to select any one, that means to select RAM or ROM or IO device, right? So see here, you can see here also chip select logic. Here you use chip select logic, right? Some address lines are going to be connected as a input to the chip select logic here to select one among this particular 3. You want to select RAM or ROM depending upon the status of this particular some higher address lines. It is going to be select RAM or ROM or IO. IO, right? Remaining lower address lines is going to be select one register among the selected RAM or ROM or IO, right? Along with this particular some address lines, higher order address lines, we have a bus I enable and A0. Bus I A0 pin, right? This bus I enable bar and A0 is going to be decided, right? Bus I enable if it is 0 and this one is the 1, it is going to be select lower even one, even part of the particular RAM or ROM, right? If it is 1 and 0, it is going to be select bus I enable. This is the higher part. Odd chip is going to be select here. Odd. This one is the even chip. Even, not even chip. You can say that even chip or even. It's going to be address even location register, right? Like that. These two pins, along with some higher order address lines, is act like an input to the chip select logic. This chip select logic function is what? Based on the condition of these three inputs, it is going to select one among this particular 5. One among this particular 5. One among this particular 5 means it's going to be select RAM even or RAM odd or ROM even or ROM odd or IO. IO it's going to be selected. That means it is going to be addressed. It is going to be addressed. This is all going to be happen only once ALE is high. Only once ALE is high, then only this input whatever is there, that is acting like input to the three latches, right? That is going to be out, right? While outing A0 to A19, right? Some higher address lines is going to be act like input to the chip select logic along with bus I enable and A0 to select this particular one among this particular 5. Once it is selected, for example, any one among this particular 5, for example, this is selected, right? So lower address lines is going to select one register among this particular RAM, one register among this particular RAM, right? So like that, this address is going to select one register along the this particular RAM or ROM or IO, one IO device. Once it is selected, then we need to look at this particular control signal, whether it's memory read or write. This memory read or write is going to be depending upon the output of this particular demux. We have a demux here. For the demux, we have inputs here. 3 inputs are there. What are 3 inputs? Memory by IO bar, read bar, write bar. These are the 3 pins coming out from the 8086 processor. Depending upon the bit combination among along this particular 3 pins, these act like input to this particular demux. Based on this particular 3 input combination, it is going to be out once control signal as a output from this particular demux. How this particular thing is going to happen? For example, this is 1, this is 1, this is 0. What is the control signal is going to be out? Memory write control signal. Why? Because so 1 means memory, 1 means it's not activate, 0 means write is going to be activated. That is the reason memory write control signal. In the similar way, 1, 0, 1. Then what will happen? This is the memory read control signal. Like that, this is 0, 1, 0 means IO write control signal. Right? This is the 1, 0, 1 means IO read control signal. Right? So that, like that, one among this particular output is going to be activated. One among this particular thing is going to be activated. That is only is going to be connected to this particular memory read, memory write, like that, IO read and IO write. So these are there. IO write is going to be connected like this. IO read is going to be connected like this. Memory read going to connected like this. Right? Once it is selected, right here, these are all not selected in our example. For example, this register is selected. Then what will happen? Based on the, for example, this is selected. This is the control signal combination outing through these 3 pins. Then memory write control signal is going to be activated. That is the reason whatever the data in the data bus, that is going to be write into this particular location. For example, this is activated. Whatever the data in the selected register location is there, that is going to be read, right? So like this thing is going to be happen. You all know that once it is addressed in the first T state by the 8086 processor, ALE is going to become low. Then what will happen? This is going to be closed. This way is going to be closed. Then it's going to be data bus is going to be activated. Data bus is going to be activated through bidirectional buffer, that is the transceiver. So process is what? First ALE is high. Whatever the bit combination through 20 address lines are there, 20 address lines data is passing through 20 pins of the 3 latches. Then based on that combination, it is going to select one chip among this particular 3 chips, right? So then lower address lines are going to be tell you what register it need to be selected. Once it is selected, based on this control signal condition, it is going to be activate one output. Based on that, one control signal is going to be activated. Based on the control signal, memory read or write is going to be takes place, right? Once it is selected, this ALE is going to become 0. Once it is 0, this way is going to be closed. Then same pins are going to be used to transfer the data, to transfer the data, right? Like this, data is going to be transferred. You know that first thing is what is going to be performed. First thing is what is going to address, then control signal, then data transfer will take place. Up to addressing, ALE is high. Once it is addressed, it is going to be low. Once it is low, this way is going to be activated. Based on the control signal, data transfer will take place, right? So look at this particular way, in the data transfer way. This is, you can see that this is the bidirectional buffer. Here 2 buffers 742445, you are going to be used 2. Why? Because each one is the 8 pin, right? So here this is enough. Only 16 lines are allotted for the data. That is the reason first 8 lines or 8 pins are going to be connected to the 8 pins of the first transceiver, and second 8 pins are going to be connected to the second 8 pin bidirectional transceiver, right? So along with this particular data transfers, right, based on the control signal, while performing data transfer, these 2 control pins are there, right, is going to be out by the processor. One is whether data is transmitting or receiving. If out is 1 from the processor, data is transmitting. That means what? Internal register data is transmitting to the any RAM or IO, right? If this particular one is 0, for example this is 0, then what is going to be doing? It is going to be receiving data through data bus from the any peripheral, right? So data enable pin is going to be tell you, if it is 0 means data is enabled on this particular data bus, right? These 2 control pins are going to work together with this bidirectional buffer, so, right? So like that, this is going to be provide bidirectional data transfers through this particular bidirectional transceivers, right? So this DMUX is going to be provide the control signal. See, this DMUX is going to be provide the control signal, right? Right, this DMUX is going to provide the control signal, right? So overall, if you look at this particular one from the starting onwards, right? So 8086 processor is going to be connected with power supply here. That is the reason it's going to work with the minimum mode configuration, right? Along with that, we need to connect some clock generator 8284 to provide the reset signal to the processor, as well as clock signal to the processor, as well as synchronization signal, ready signal to the processor, right? Then we are going to use multiplexed address and data bus and multiplexed address and status pins to provide the address as well as select signal to the particular peripherals. Then these three pins are going to be used to provide the control signal to the peripheral. And third thing is, so same address multiplex lower address and data lines, in which 16 data lines we are going to use to transfer the data from the peripheral to the processor. That is the reason first 20 address lines used to select this particular device as well as to select the particular location or particular number device in the IO section. Then control signal, then data transfer will take place. Right. So here is what this multiplexed address and data lines as well as multiplexed address and status lines are demultiplexing using ALE signal. Once ALE is high, right, it is going to be act like an address to select the chip as well as to select the location, right? Then processor is sending control signal. This control, based on this control signal, this control action will take place based on the data receiving or transmitting through the data bus. By that time ALE is going to become 0. Then it's going to be closed this way, right? Then data transfer will take place through the bidirectional data trans receivers, right? So like that, this particular minimum mode configuration is going to be work to communicate with external peripherals, right? Thank you. In the next class we will discuss maximum mode configuration, right?